Okay, so let's try a few more solutions to this one. It is really important to understand the idea of solving this thing, but one really important note, and especially when you've got multiple terms that you're going to be dealing with here in an expression like this, we have to know that anytime you get a solution to one of these equations, you must check the proposed solution. It's not always possible that every single solution does, and by squaring both sides to get rid of a square root, for example, the problem that we're going to run into is that we could generate what's called an extraneous solution. That is, a solution we've obtained through the normal means, but when we check it, doesn't work. I'll give you an example. Let's try this one. We're going to solve for x in the equation. X plus 3 times the square root of x minus 2 equals 12. So we would start by isolating our radical right here, and I'm going to start by just subtracting x from both sides to get 3 times the square root of x minus 2 equaling 12 minus x. Okay. Now, we could divide by 3 on both sides, but this is actually pretty good. At this point, we could square both sides. When we square both sides, note what's going to happen on the right-hand side. We are going to get a quadratic form equation. On the left, 3 squared is going to be multiplied by the square root of x minus 2 squared, which undoes that square root. So we're left with 3 squared times x minus 2, and that is equal to, let's see, 12 minus x squared. That's going to be 144 minus 12 times x times 2, right? This is one of those special form multiplications. So minus 24x plus x squared. So if we carry this out, of course, this is like saying 9 times x minus 2, so 9x minus 18. And I'm going to change around the order of my terms over here on the right so that I have positive x squared as my first term, minus 24x plus 144. And so our next task right here will be for us to move all the terms over and set the equation equal to 0. So if we subtract 9x from both sides and add 18 to both sides, so I'm going to subtract 9x here, I'm going to add 18 here, we're going to get 0 is equal to x squared minus 24x minus 9x is minus 33x plus 144 plus 18 is plus, let's see, 4 plus 8, that's 12. Carry the 1. 1 plus 4 plus 1, 6, and 2. So we need to find factors of 162 whose sum is negative 33. So we think about this one. So we break up 162 as 6 times 27, right? And we'll note that, well, 6 times 27 is 162, and the sum of 6 and 27 is 33. So we should actually make both of these negative, and so when we break this up, we're going to get x minus 6 times x minus 27. All right. Now, if we set both of these factors equal to 0, we're going to get x equals 6 and x equals 27. Now, do both work? Well, that's the question. We actually need to check this one out. So we should make sure that we check by going to the original equation. Let's take a look at x equals 6. Does that work? Well, if it does, then 6 plus 3 times the square root of 6 minus 2 should be exactly the same as 12, is it? Well, this is 6 plus 3 times the square root of 4. And 3 times the square root of 4 is 3 times 2, so that's like saying 6 plus 6. And sure enough, that's equal to 12, so that one works. How about the other one? Well, if we go back to our original equation, it should be the case that 27 added to 3 times the square root of 27 minus 2 should equal 12. Well, you can already see that this won't be the case, because 27 added to 3 times the square root of 25, which is 15, right? 3 times 5 is 15. 27 plus 15 does not equal 12. And so this solution would not work, right? And so we would say about the solution x equals 27 that it is extraneous. And so our only solution is x equals 6. Okay, so we're done with that one. What about this next one? Now we've got a lot more going on, it looks like. If you have more than one radical in an equation and you want to solve it, you're probably going to have to start isolating radicals twice, and let me show you why. What we should do is isolate either the square root of x or the square root of x minus 5. And in my book, isolating the square root of x minus 5 first is easier. Why? Well, if we subtract the square root of x from both sides, we get a new equation that looks like this. The square root of x minus 5 would equal 5 minus the square root of x. And what we have to do to eliminate the radical here is square both sides. Now be very careful, because on the left-hand side, it's no problem for us to square our square root and undo anything that was there. So we'd get x minus 5. That's no problem. However, on the right-hand side, we are taking the quantity, 5 minus the square root of x, and squaring it. And that requires that we use the FOIL method. Okay? So be very careful right over here on this left-hand side. What's got to happen is that on this right-hand side, because what's got to happen next is that we're going to have to actually carry out the FOIL method. And I'll do it up over here, right? We might note that 5 minus the square root of x squared is 5 minus the square root of x times 5 minus the square root of x. Oh boy. All right, so that means we're going to have to actually FOIL with a radical in here, and we're going to end up with a radical expression, because we'll get 25 from our first terms. We'll get minus 5 times the square root of x minus 5 times the square root of x from our outer and inner terms of our FOIL method multiplication, plus the square root of x quantity squared. This is the same thing as saying 25 minus 10 square root of x plus x. Okay, so here's what we've got now. We've got 25 minus 10 times the square root of x plus x. And so what we have to do is that we have to, a second time, try to isolate our variable. So here's what we're going to do. We're going to subtract x from both sides, which is nice for us because that means all the x's go away. Goodbye. But we do subtract 25 from both sides, so subtract 25 from both sides, subtract 25. And we're going to get negative 30 is equal to negative 10 times the square root of x. And we can do a little bit more isolation right here, because I don't like mixing my negative signs and my radicals if I can at all avoid it. So I'm going to divide both sides by negative 10, and I'm going to find that 3 is equal to the square root of x. So now, if I square both sides of my equation in order to undo that radical, we get 9 is equal to x. That actually seems nice. Will that work? Well, let's try it out. We must check. So in this case, when we check our solution, what happens? We're going to get the square root of 9 added to the square root of 9 minus 5 as being equal to 5. Does that work? Well, yeah, sure, right? We've got 3 added to the square root of 4, and we're saying that's equal to 5, but of course it is, because 3 added to 2 is indeed 5. So we're done. More in the next video.